Hi everyone. Thank you for joining and taking the time to listen to what I have to say. I am very excited and I hope you are too. So, I'm going to present today the multiplayer online game in Clojure Menace, episode 1. And it's episode 1 because there's going to be an episode 2, but I'll talk about this later. Let's start. So, let me start with introducing myself. My name is Mey Beisaron. I am a software engineer. I am a backend developer at AppsFlyer. Currently, I write daily in Node.js, Clojure, and Go. Recently, I started Go. And I am a public speaker, which means that I talk a lot, but I have a title for that because I don't only talk a lot in general, I also talk a lot in conferences. So it's cool to have that official, you know? And yeah, I'm a sworn Star Wars fan. Yay! All right, let's go. So, like a good Clojure talk, I'm not gonna start by talking about Clojure. I'm gonna start by talking about how I recently learned Go. And in order to learn Go, just like I did with Clojure, I decided to develop a multiplayer online game, which was kind of cool. The game is named Exceptional Monkeys because I thought it's funny to do a game about exceptions, and in Golang there are no exceptions. I don't know, made me laugh. Maybe I'm easy crowd, you know. The backend was written solely by me, and the front end was written by the very talented Roy Berkovich. He's a very good friend of mine, and he did the entire front end of this game. 350 lines of code. This is what it took in order to write the backend of this game in Go, and it was okay. It was kind of fun, and because it's Corona time and I have a lot of time at home, I got to thinking about my first Clojure talk. And in this talk, what happened was, in most conferences that weren't actually like Clojure conferences, I had people approaching me later after I finished my talk, and they said something like this. They said, Clojure is nice, but if you ever decide to write a multiplayer game, you can't do it in Clojure, right? And you know, I was a Clojure newbie, so I didn't really know if they are right or wrong. But what I can tell you is when you tell a developer that, you know, they can't do something, the first thing that comes up to my mind is, I'm gonna do it. I'm gonna do it. I'm gonna write a multiplayer game in Clojure. And I did. And you know what? 100 lines of code. That's it. That's all it took in order to write the same exact game in Clojure, completely translated from Golang to Clojure. Bam. I love Clojure so much. Okay, so I'm gonna show you a quick video of the day that I deployed it. Yeah, so anyway, I deployed the game on Heroku and it was perfect. I was super happy about it, and that's it. That was the end of the journey. So what we're going to do now is I am going to take you through the same journey that I went in order to write this game in Clojure, I mean the backend. And my journey started with the communication between the clients and the server. Because I've written 2D games in Clojure before, and I found this part to be a bit more challenging. And let's see how it went. So over here you can see a very simplified image of how a communication is supposed to go between clients and server in a multiplayer online game. What it means is if player 1 made a move, then it informs the server that this move was made, and then the server has to tell all the other players, including the one who did that move, that a move was made, which means that the state of the game was changed. It means that the server needs to update all of the connected players about the new state of the game. Okay, so this type of communication requires an ongoing connection between the client and the server. We want that the client won't have to pull the server in order to get the new state of the game. We want the clients to get the new state of the game once it is happening, you know, whenever the server is wants to send it, right? So the right protocol for that is Websockets. Websockets is communication protocol which allows the client and the server to have an ongoing connection, and this is how we are able to do this multiplayer thing. So this is how this is how the flow of the WebSockets go. So we start from the client and it sends an HTTP request that includes a request for upgrade, right? So it sends a normal HTTP request and it asks for an upgrade to a WebSocket connection. And then if everything is okay, then the server returns that everything is okay and a connection is open. Right there and then we have a bidirectional messages channel between the client and the server. This is the ongoing connection I've been talking about. And this connection will end once one of the sides will decide to close this channel. So I've been looking for a few libraries of WebSockets in Clojure, and I decided to go with a mutant just because it had enough examples and it was very simple. And I mean, that's all I need when it comes to Clojure, to have enough examples and for that to be simple enough. That's all I need when I start with something. So now I'm going to talk about how I used a mutant library in order to implement the WebSockets part in the game. All right, so what we see over here is this. We have the wrap WebSocket function, which receives the routes function, and also it receives the WebSocket callbacks function. And the wrap WebSocket function returns an HTTP handler. What it means is that we need to put it at the end of the flow of your web middleware flow, because then this HTTP handler will be sent into the run function, the web run function, and what it does is it binds the routes function to the ring request, right? And then it binds the WebSocket request to the WebSocket callbacks. Okay, so now what we're going to do is we're going to look inside the WebSocket callbacks function. So this function actually returns a map of events, and over here you can see an example that I used from Heroku document, and this documents from Heroku that actually really helped me to better understand how to use the WebSocket library, and more specifically the WebSocket callbacks, because here it's very clear that we have the onOpen, onClose, and onMessage. These, I think that there is one more event, but correct, like I'm not sure, but these are the main events that I used, and each one of them gets a channel, which is an async channel, and and let's say that in the onMessage it will also get the message that was received, and in the onClose we get the channel, and then we also get the code and the reason for why the connection was closed. The reason that I am being very specific about it is I want you to understand that this is a one-directional channel. Later on, you will see that I am only able to send messages to this channel, and I am not actually reading messages from the channel. I am getting the message separately, okay, in the onMessage function. You can see that in the input to the function. So in this example, in the onMessage function, you can see that I'm actually using the channel and then as the input to the send message, to the send function, and then I'm also using the message that I just got, I'm doing a reverse, and then, and then that's it. I send it to the same client that just sent me this message. This is how I started my code. And the next step was to create another function and to create a list of, or a map, not a list, a map of all connected clients. So this way I can get a new client, save it, and then later on I can send a message to all connected clients. And this is the broadcast message function. So we still have the same WebSocket callbacks function. All we have now is the broadcast message function, which only sends a message to all connected clients. Okay, so now we've come to the most important state of the WebSocket callbacks function. The way that you see it right now is, this is how it's it is right now. This is the final state of this function in my code. What it means is I wanted to create some sort of library framework that enables people who never wrote multiplayer game to do it and very easily. And even if you've never used WebSockets before, you can take my code and implement any game that you want, any simple game that you want, and get to know the WebSocket thing and how to handle different connections. So all you have to do is to implement the add new player, remove player, and move function. And you can actually use the example that I already did right here. And we're going to go through it right now, actually. So I'll show you how I implemented the add new player function. And what we have right now is I manage the players as a map of keys and values. The key is a channel that we get, the async channel, as I mentioned before. This is what we get from the on-open callback function. And since this is a unique identifier, this is how I can identify each and every unique player. So the value of this map will be the actual values of the player itself. So then you can see that inside the add new player function, what we have is I'm calling four functions underneath it. The first one is in order to add to send the player to himself, okay? And then later on we have send the player all of the existing players, because if there were already players in the game before I joined, I want to see the ones that were already there. And then I am sending the new player to all existing players, and by the end of it, I'm just inserting the new player to the map that holds all of the existing connections. So this is fairly easy. And if you are now going to develop your own game, all you have to do is to change the player map over here, and that's it. Basically, you have it going, right? Because this is already implemented. All you need to do is to change the player object, and you've got your own game. Next thing that I'm going to go through is the remove player function, which is also very, very simple. What you can see over here is that I am using the connection, which is again the channel, as the identifier for the player who closed the connection, who actually maybe closed his web browser and exited the game. What I'm doing is simply using swap to dissociate that player from the list, and then later on I'm broadcasting the message to all existing players with about the fact that now there's a new game state, which means there is one less player in the state of the game. And now I'm going to go a little bit, because we don't have a lot of time, I'm going to go a little bit about the move function. But listen, I'm not going to dig into this function, nor also to the collect function or the collision, because these functions they can change depend on the game that you're trying to create, right? What I want you to take from this talk today is I want you to see how easy it is to implement a simple game using WebSockets, and you can use my game as a basic, right? As a structure that you can take from it and just put inside whatever game logic that you want, and that's it, snap. You'll have a 2D simple game, multiplayer, right? If there's more than one player, isn't it multiplayer game? Okay, so over here we have the overlap and collect, which means this is where we collect items. Like if our player walks around the screen and there are items to be collected, this is where I handle it. And I think we got to the most fun part of this talk. It's demo time. Whew. Is it getting hot in here or what? Okay, let's do it. So let's do it and go see the demo. All right, wish me luck. Okay, so what I'm going to do now is that I want you guys to see I opened two tabs. Let's go back. Let's load my game over here. And okay. Yes. Okay. Are you ready? Okay, waiting for other players to play, and that's it. We now have two players. In order to identify myself, it means that I have a little crown on top of the player. And what you can see over here is that each of these players, they have like a little exception above their head, which tells them which kind of exception they're supposed to catch. There you see, a move between the tabs. And you can see that there are different exceptions going around the screen, and there are a lot of null pointers, exceptions. That's not nice. And I gotta tell you something about it. Oh wait, let me show you how I'm gonna catch like this one. Yay, I collected it. All right, let me tell you a funny thing about developing a game that has entities that are exceptions. When there are exceptions in the language, that's not funny, because I opened, in the web browser, I wanted to see that I get, what I'm getting from the server, and I see that I'm getting a lot of exceptions. And then I was like, wait, oh yeah, what? Anyway, not sure that my next game will be again me playing with exceptions, but okay, that's just me. Let's go back to the presentation. We're almost done, but woo! I did it. That was the demo. Oh, God, I love this game so much. Okay, let's wrap this up. So, I told you at the very beginning of the presentation that this is episode 1, and this means that there's going to be an episode 2. So, what you saw today was a very simple implementation of a simple 2D multiplayer game. And I showed you how to do it with WebSockets, and I also told you that you can take my game and that you will be able to use it as a general, code in order to insert your own logic and create your own simple 2D game. And there are a lot of things that I didn't explore yet with this code. I didn't check for, if there is like different loading time between different players. I didn't check for different types of errors. I didn't even check for, load. Like what happens if, what I'm trying to say is I did not check how resilient my code is, okay? I don't know how scalable this code is. And I know as a fact that there are a lot of improvements that I can do, and I know it because I'm already working on a higher scale multiplayer game, but that's going to be left for the next episode. So thank you for listening. Bye.